Welcome to SAT Maths 002 and our video SAT Maths 001. We talked about solutions of linear equation in one variable. We talked about the different types of solutions. We talked about no solution, one solution, and infinitely many solutions. So you can check the video if you have not seen the video before. So today we're going to continue from where we stopped. So today we are looking at linear equation, the solution in one variable, special case. So this is special case. So special case is what if you have something like if AX plus B is equals to BX plus Q. More like something like this. If 2x plus 1 is equals to 5x plus 3. This is the kind of case I'm trying to explain here. So if you have if AX plus B equals to BX plus Q, we want to see at what point with this kind of equation you want solution. At what point will it be no solution? At what point will it be infinitely many solutions? Now let's look at them one by one. It will be one solution if the coefficient of x on the left hand side is not equal to the coefficient of x on the right hand side. That is, coefficient of x here is coefficient of x here is a, coefficient of x here is b. So if a is not equal to b and the constant on the left b is not equal to q, then it is one solution. The coefficient of x are not equal and the constants are not equal. Let me give you an example. If I have something something like this now, like what I wrote here, 2x plus 1 is equals to 5x plus 3. This is an example of one solution. Why? The coefficient of x here is 2, the coefficient of x on the right here is 5. So 2 is not equal to 5. What's our constant on the left? 1. What's the constant on the right? 3. So 1 is not equal to 3. So that means that if I solve this, I will have an answer for x. I have an answer for x, which is one solution. So that is the condition for one solution. If you have them equated like that, then this will be no solution if the coefficient of x on the left hand side, that's your a, is the same as the coefficient of x on the right hand side. That means if a equals to p, if a equals to p and b is not equals to q, that is no solution. Let me give you an example. E.g., let's say I have something like 5x plus 2 is equals to 5x plus 7. This is an example of no solution. Why? Coefficient of x on the left hand side is 5. Coefficient of x on the right hand side is 5. So a equals to p. Don't forget that a and p are the coefficient of x on left and right. So a equals to p. But the constant on the left is 2, which is b. Is not the same thing as the constant on the right. So this is an example of no solution. So anytime you're trying to solve a linear equation and you discover that you compress to this form of ax plus b equals to px plus q, and discover that the coefficient of x on the left hand side is the same as coefficient of x on the right hand side, but their constants on the left and right are different. That is no solution. But if the coefficient of x on the left and right are not the same and the constants are also not the same, that is one solution. Then the last one, obviously, is a infinitely many solution. Infinitely many solution, I will not waste too much time. For that one, a is not equals to p, like a equals to p, and b equals to q. But all of them are like the same thing. That means the coefficient of x on the left is the same as coefficient of x on the right, and the constant on the left same as the constant on the right. So let me give you an example here. That's more like, let's say 5x plus 2 is equals to 5x plus 2. So that is infinitely many solutions. So let's see how SAT is to ask the kind of question without wasting enough time. Alright, look at this question here. This is SAT question. They said if 4ax minus 2 over 3 is equals to 2x minus 1 over 3b. In the question above, a and b are constant. If the question asks infinitely many solutions, what is the value of ab? This is very easy. Don't forget what we said. Let's write it again. If I have ax plus b equals to px plus q for infinitely many solutions, a must be equals to p and b must be equals to q. Now the coefficient of x on the left must be equals to coefficient of x on the right, and the constant on the left must be equals to constant on the right. So look at this case now. What's our coefficient of x on the right? In this case now, if I have something like so coefficient of x on the left here, is 4a. So that's more like 4a. Coefficient of x on the right here is 2. So that's more like 4 equals to 2. In this case from here, I have a equals to 2 over 4. And a equals to half. Then the other one here, our constant on the left here is minus 2 over 3. Our constant on the right here is minus 1 over 3. So minus cancel minus. 3 can cancel 3. B equals to 2. So what I have to find? AB. So AB is more like 1 over 2 times 2. 2 cancel 2. That's 1. So that's option B. Let's solve another question. This question, the question here says, if 3as minus 7 equals to 6s minus 7, if a is a constant, for what value of a does this have an infinitely many solution? The same approach. Infinitely many solution, a equals to p and b equals to q. So our a coefficient of x here is 3a. Our coefficient of x on the left hand side, on the right hand side is 6. So a is 6. So a equals to 6 over 3. So a equals to 2. I've got my a already. So there's no point doing b and q. The constants are already the same, so that shows it's an infinite many. So answer here is option B. Next question. Look at this question here. It said if minus 3s plus 21 ps equals to 84, what is the value of p for it not to have no solution? So what you do here is that I have minus 3x plus 21 ps. So what I will do here is that I will factorize. Let's factorize. If I factorize, if I bring x out, I will have minus 3 plus 21 p is equals to 84. So this is more like, it will be something like, open a bracket, minus 3 plus 21 p x plus 0. Don't forget that I want to have something like a x plus b is equals to p x plus q. So in this case, my a is like minus 3 plus 21 p. So this is the x here. Our b is like 0 for the left hand side is equals to our px here means there's no, I only have a constant on the right hand side. So the constant on the right hand side is 84. I don't have anything px, so I can just write 0x plus. That means more like p is not 0. A is all of this. So for it to be no solution, don't forget, for no solution, A must be equal to P. So our A in this case is now minus 3 plus 21P is equals to 0. That's A equals to P. A equals to P. So from there I can have 21P is equals to 3. Equals to 3. Then I have P is equals to, I have P equals to 3 over 21. And that is 1 over 7. And that is the end of that. So you can try these practice questions and solve them, and you can screenshot it, solve them, and put your answers in the comment section.